Okay, good evening, everyone, and thank you for joining the first part of the lecture notes for the class tomorrow. As I explained it on Wednesday, the class will be canceled tomorrow. There is an announcement on Brightspace. So if I'm gonna go ahead and then share the entire screen, I'm gonna, okay, here we go. Let me go over quickly before I get into topics that will be covered in the first part of this video recording. Let me start off with the class cancellation announcement. So this was posted on Wednesday, right after our class. Um, I'm referring to the class on Friday that will be canceled. As I said, as I've been attending a conference tomorrow. I'm also reminding you that quiz number 2 online is scheduled for tomorrow. You still have a couple of hours remaining to download the Lockdown browser. As I explained, there's an assignment that is created on Alex only to allow you to download the Lockdown browser. So log in to Alex, and then once you log in, you go to Alex, and then if I make myself a learner or a student, I will show you through the student view that this Lockdown browser assignment is available. It's gonna end tonight. This is not designed for you to answer any question, even though there is a question in there. And the reason why you see one, because otherwise it's not possible to create the assignment. But take this assignment just to download the Lockdown browser. Alex Lockdown browser works very well with any Windows and Mac system. If you're using a Chromebook, you're not going to be able to download it. In that case, in the absence of any device, you must take the quiz to the testing center. You need to let me know. Send me an email and let me know that you do not have a device to take the quiz online. And therefore, we'll schedule time for you to take it at the testing center, and that's going to be right after the break. Quiz number 2 is scheduled for Friday. So that's why I'm encouraging you for the remaining time tonight to download the Lockdown browser, take care of all technical issues before you take the quiz tomorrow. And now let me get back to the announcement. A quiz is going to be available tomorrow throughout the day, 24 hours. But once you click, you only have 90 minutes to take the quiz. And let's go over a couple of directions for the quiz online. So if I go to quiz 2 online submission rules, reminding everyone, please read the honor code for the submission. This is 1.5 hours, which means 90 minutes. Quiz is going to be available throughout the day tomorrow from 12 a.m. to 11:59 p.m. But once you click, there's only one attempt. The quiz starts. So if you decide to exit out or close, you're not going to be able to go back. So be very careful. You are required to use the responders, the Lockdown browser. Now, once you click and then assuming that you already took care of that download process of the Lockdown browser prior to taking the quiz tomorrow, under that assumption, you will be directed to the online quiz. Make sure to have a webcam on and make sure to have an ID that you are going to display in front of the camera for me to see that you are the one taking the quiz. You are allowed to use one piece of scrap paper for scratch work, and that's going to be the piece that you're submitting. So in addition to Alex submission, I would like to see your scratch work in case if there is anything entered incorrectly, then I should be able to see your work. And these are the rules for you to submit the scrap paper where I can see your handwritten work. Be very careful. You only have 15 minutes. Once the quiz is submitted, 15 minutes to submit the work to my email. You can use an Adobe scanner through your smartphone once the quiz is submitted. Within that time frame, 15 minutes, you only have one piece of scrap paper You can either scan it or take images and then send it to my email. If for any reason you have work front and back and you're taking two images, you need to submit both of them using the same email. So read this very carefully. Hopefully everything is going to be successful tomorrow, and then good luck, everyone. Now let me get to, the other reminder for all of you, continue to do the work on Alex. So you should continue to do the work on Alex. Tomorrow is a good day. Since class is canceled, you have the time to either take the quiz during the time or do the work on Alex. During the break, as I mentioned, during the class time, I'll be happy to extend time for the homework assignments that you did not perform well and you want to go back and revisit. I know that in some topics that I explained in class on Wednesday, such as graphing, domain, range, limit computed graphically, continuity that we discussed together, removable, non-removable points of discontinuity. I know that some of you did not perform very well the first time you attempted the homework assignment. So if you feel like you want to go back and then use explanation that I did in class on Wednesday, and then all the lecture notes that I posted afterwards, the examples I showed in class, then you can go back and then be able to retake the homework assignments. And when you retake it, you're only taking the ones that you did not do well to not only learn the topics, but improve your overall grade of the homework assignments. It is also important to be on Alex constantly. I'm not asking you to stay there all the time, but I'm asking you not to wait, as I explained in class, for the last 30 minutes before the deadline to complete it. As I'm reading through the reports, I see some of you spending a good amount of time and doing practice almost every day, but some others, unfortunately, wait for the last minute to complete the assignment. It's almost impossible to do it waiting for the last 60 minutes or the last 30 minutes before the deadline to complete the homework assignment. It's not going to be beneficial in the long run. It's homework assignments are designed not only for you to get grades and then improve your overall performance, but at the same time, it's an excellent practice. That's your tool to learn the topics and then perform well on all other assignments. Now let's get to the topics that I would like to go over today. By the end of class on Wednesday, I did an introduction of, so I'm gonna stop sharing this slide and then I'll go back and then share the file. I did an introduction of what I call the limit definition of the first order derivative. I also ended out some additional notes for you to have it. And then in that part, in that particular file listed as the additional notes, you do have some examples starting with the number 14. Now, these particular examples are asking to find the equation, one of them of the tangent line, to the graph of the given function at the given point using the limit definition of the first order derivative. So I'm going to be more precise of the first order derivative. So what we do in this case is find a right equation of the tangent line. Now, as we all know, there's a big distinction between tangent line and secant line. Secant line connects 2 points on the graph. Then as long as you know the coordinates of the two distinct points, you can find the slope. And then from there, you can find the y-intercept and the right equation of the line. In general, the equations of the line are given in the form of y equals mx plus b. So you only need to find the slope and the y-intercept to write the equation, which can be done if you have 2 points and you know the coordinates of them. That's more like a algebra 2, algebra 1 pre-calculus question. Now, why we are revisiting this? We're not finding the equation of any secant line. We're finding the equation of a special line known as a tangent line. And tangent line is the line that touches the graph in exactly one point. So it's not the case of you using the slope formula to find the slope of the line by using the coordinates of the 2 points, because you only have one. So in that case, we're going to find the equation of the line in a very similar way by still finding the slope and the y-intercept. But the approach that we take to find the slope is through the first order derivative of the function. And then here is the connection. So I'm going to start off by adding the slope of the tangent line, and then I'm going to not only underline but highlight this. Add the slope of the tangent line to the graph of the given function is equal to the first order derivative at the given point. So what I'm saying is m is equal f prime of x at the given point. Now the question is, how do I find now the question is, how do I find the we can compute the first order derivative by using the limit definition or the basic rules of the derivatives of differentiation. Now, for these particular examples, number 14, 15, and 16 of the additional notes, I'm only focusing on finding the derivative using the limit definition, because I really want to practice more than once to show how to use the limit definition to find the derivative. And then we'll transition into using number 15 and number 16, which are only asking you to find the derivative using the limit definition. They're not designed to find the equation of the tangent line. Number 14 is the only one requiring the equation of the tangent line. And for that reason, you need to not only find the derivative, which eventually becomes the slope when the coordinates are plugged in, but you have to do an additional step, finding the y-intercept using the slope to write the equation in the slope-intercept form. So that part is going to be an additional step only for number 14. 15 and 16 are only computing the first order derivative using the limit definition. And for those two questions, once we finish finding the derivative using the limit definition, we're going to apply for the first time the basic rules of differentiation and use the basic rule to find the first order derivative. As you will find, it's going to be a shortcut to transition to the basic rules. Okay, here's the work. So now let me start by saying, what is this limit definition that I've been using it at least twice. So you have the delta x approaching 0. Now this delta x is just one term. So it's not a delta separated from x, it's not a delta times an x, it's just a delta x one term. Think of it as having one variable. Could be an a, okay? So that's delta x. Of the ratio f of x plus delta x minus f of x all over delta x is equal to f prime of the variable x. So that means if I'm going to find the derivative, I have to find this limit. And then the limit is the limit of this ratio. So that means I need to identify what is this f of x and what is f of delta x. So if I know f of x, how do I find f of x plus delta x? Now, f of x is what is given as a function. So that is variable y at x. So let's go ahead and then define them. And then if I know f of x using the function notation, so this is f of x. Using the function notation, I should be able to define f of x plus delta x. So in order to define f of x plus delta x, that I have to use the expression of f of x, but wherever I see x, I have to substitute it by x plus delta x. So you notice the substitution. X is substituted by x plus delta x raised to the second power. And then at this point, all I have to do is simplify. So to simplify, I'm going to keep 8 as it is. And then I have to write x plus delta x as the product of two of them. Because if you're squaring, that means the expression is multiplied by itself. So it's going to be x plus delta x multiplied by itself. You notice that the second product is the case of foiling. So I'm going to foil, but I will continue to keep parentheses as they are. The reason being, if I do not keep parentheses, then I might end up creating algebraic errors due to the presence of the minus sign in front of it. So I'm going to say 8 minus, and then I'll continue to keep parentheses, and then I start foiling. So be very careful. When I foil, I have x times x, which becomes an x squared. Then I have an x multiplied by delta x. That's going to be x, just x delta x. Those are two terms that don't have anything in common. When you multiply, you write them next to each other. This is the same as multiplying x by z. You write it as xz. That's going to be the case for the other one, delta x times x. It's not delta x squared because delta and x are not separated. That's not a product. Delta x, you think of it as a z, okay? That's why I explained it in class on Wednesday. I said in many scenarios of these technologies, they use the lowercase h to avoid any confusion. So I'm going to write this as x delta x again, and then plus at the end. If delta x is multiplied by itself, that becomes a delta x raised to the second power. So notice parentheses around it. So it's not delta square x squared, okay? It's just delta x. Think of it as a z. So it's going to be z squared. In this case, it's delta x squared. And now I can distribute the minus in front of it. So that's going to be 8 minus. Let's see if I can copy these elements. So x minus x squared. Then I have another minus due to the distribution. If you notice the terms in the middle, x delta x are like. There are no coefficients in front of them. So when you combine like terms, you don't change the variable, you just combine the numbers in front of them. And since I have two of them, 1x delta x plus 1x delta x, that's two of them. So minus 2x delta x, and then finally minus this delta x raised to the second power. So I'm going to write it at the end. So this entire expression represents f of x plus delta x. And now what f of x plus delta x, now that I know what is f of x plus delta x, I can go ahead and then substitute it to this ratio. Here's the ratio, and then I'm going to simplify this ratio before I take the limit of it. That's kind of like ideal. So here's the ratio. So we start with the expression that is representing f of x plus delta x. Here's the expression that represents f of x plus delta x. Then I have a minus again in front of f of x. This is f of x. Be very careful. Notice that I use parentheses again. Why am I using them? Because I'm concerned of messing up the distribution of the negative sign. So that's why I use parentheses all the time. And then in the denominator, of course, I have delta x. Okay, so now I'm going to go ahead and then simplify. And see what the outcome is going to be. So simplify means eliminate parentheses and distribute the sign. So if I distribute the minus sign to the second part, it's going to be minus 8 plus x squared. And then as you notice, some terms are going to cancel out. The denominator is going to stay the same, but at the top, number 8 will cancel out. Let me try to use some color coding. Let's see if I can highlight this. Yeah, I kind of like use the green color for number 8. Oops. So number 8 cancels out. You have a positive 8 and a negative 8. And then x squared also cancels out. You have a negative x squared, which I'm going to make it blue. And then a positive x squared, that's another blue. So that cancels out. So what remains is just these two terms in the middle, which I'm trying to copy. Let's see if that's going to work. Yeah, it does. And then let's see how that's going to be simplified. So I'm going to put a sign in there and then transition into my next step. So I'm going to copy this one, and I'm copying all this just to save some time. I'm going to get rid of this term in the middle, and then I'm going to try to simplify. Now, what's the way I approach this? I notice that I have a delta x in the denominator, but then I also notice that both terms in the numerator have a delta x. So I'm going to factor it out. And then if I do, negative 2x is going to remain from the first term, and minus delta x. I have two of them, so one is factored out, the other one remains. And that's going to allow me to get rid of delta x. So this delta x in the denominator, and then this delta x in front of it, which is a common factor, they cancel each other out. So what remains is this expression inside. So that's going to be the ratio of f of x plus delta x minus f of x over delta x. So now what we do with this ratio, very simple. I'm going to grab the limit now. Remember, the limit of this ratio is delta x goes to 0, represents the first order derivative. So I'm going to take this limit, which means I have to take the limit, not a ratio, it will be the limit of, let's see if we can. So the limit is delta x approaching 0. So when we see delta x, this is going to be done by substitution. Oops. And now what goes to 0 is this expression, right, which represents the ratio. And then I think we should be able to take this limit. So that's going to be negative 2x, because x is not going to 0, delta x is going to 0, minus 0. So altogether, this is negative 2x. And what is this negative 2x? Is the first order derivative f prime of the variable. So through the limit definition, I was able to compute the first order derivative. Here's the first order derivative. F prime of x equals negative 2x. And what we do with the first order derivative. Now, the first order, as you see, is an expression of a variable x. As you know, Slope is a number. So how do I change this into a number? Let me go back to what I just said. The slope of the tangent line to the graph of the given function is equal to not only the first order, but the first order at the given point. So in order for me to change the first order into the slope of the tangent line, I have to use the given point, which in this case is 0.5, -17. So that means x is 5, y is -17. And then f prime of x, as I said, is going to become slope m if x is, in this case, substituted by the value of x, which is 5. So that's going to be -10. So therefore, the slope of the tangent line for the given point is going to be 10. So we just computed the slope of the tangent line to be 10, and then we do have a given point. So slope is -10, and we do have a given point. So what I'm going to do is I'm going to use the coordinates of the given point and the slope, plug them into the slope-intercept form, and then find the missing element, which is the y-intercept. So let's do that. So as I said, m is -10, x is 5, y is -17. This is the slope-intercept form. So I'm going to replace y by -17. I'm going to replace m by -10, replacing x by 5, and then b is unknown. The product of -10 and 5 is a -50. And then if you add 50 to both sides, b is 33 and m is -10. So that's going to be the equation of the tangent. Okay. I hope that is. So all these lecture notes that I'm going over will be posted along with video recording to allow you or give you the opportunity to follow, not only watch the video recording, but look at the lecture notes and then try to follow and then understand the video recording. I'm waiting for the PDF file to be created. There you go. Because it will be posted as a PDF file in Brightspace. Okay, now let's get to the two additional examples. The two additional examples are finding the first order derivative of the given function. Now we can do it using the limit definition. So I'm going to do one, and then I'm going to ask you to do one. Since I already showed you one with the quadratic form, makes sense to do a one with a cubic, the exponent 3, and then assign this number 15 for you to practice on your own. You can mimic the solution of the way I computed the derivative, the first order derivative, using the limit definition in the previous example, and try to do it on your own for the number 15. I will revisit, so let me write this down, please. Now you try it. Okay. There you have it. And then I'm going to repeat the limit definition now for number 16. So there's certain things that I'm going to copy from the previous one, so I don't have to retype this. And then that's what I'm copying right there. So when I say now you try, that's for number 15. I'm still doing number 16. The reason why I selected 16 because of exponent 3. So number 16 has an exponent 2 and an exponent 3, which makes things a bit more difficult. Okay. So for number 16, f of x is well defined. So it's this function. Now we need to find f of x plus delta x. So let's see how that's going to look like when we plug it in. So once again, let me go back. There you go, right there. So I can still use some of the form that is in there and then adjust it. And you will see me adjusting it. Okay. So f of x plus delta x. F of x plus delta x is going to be 5 times x plus delta x raised to the third power. So let's get to the delta x. Now all this is raised to the third power. There you have it. Minus 3. Okay. Let me move this to the side. Minus 3, so I'm reading f of x. Where I see x, I substitute x by x plus delta x. So here's the other one. So this one is to the second. And then ends with a minus 4. Okay? So notice that you see f of x plus delta x. I'm looking at f of x. Wherever I see x, I replace x by x plus delta x. So it's f5 times x plus delta x to the third minus 3, x plus delta x to the second minus 4. Now what I'm going to do next, since I have two interesting expressions, one of them is this x plus delta x raised to the third power, I'm going to separate them and then try to compute them first, and then I'll come back and then plug them in. So this one is the product of x plus delta x by itself 3 times. So what you're doing is you're multiplying this by itself 3 times. Here's another multiplication notation. Okay. So when you multiply, that means you can FOIL the first two. You only FOIL two binomial. And then whatever the outcome is, then you multiply it with the third. Now, I already FOILed an expression that looked like this, okay? So what I'm going to do is I'm going to copy and paste this. Because I already FOILed this. And now I still have to multiply. This is FOILing the first two. I'm hoping you're following me. So if I multiply x plus delta x by x plus delta x, that's the expression, okay? That's what I did when I squared it. Square is multiplied by itself. And then I still have to multiply by the third. So now this is different because you have 3 of them, okay? So let's see how this product is going to look like. So we are still doing this. So I have to go on to the next step. So we're still doing this. So now I'm going to distribute. But before I distribute, the expression that is the two terms that are in the middle of the first one, I'm going to combine them into 2x delta x. So I have to rewrite this one more time. Adding an additional step is not going to hurt you. And then instead of using them twice, I'm going to combine them in one. because there's two of them. They're equally the same. They're like, okay? And then let's transition into what we do now to raise this, to distribute it, okay? So if I distribute it, that means I'm going to take each term of the first one and distribute it to both. So that means I'm multiplying x squared by x. So that is going to generate an x to the third. So once again, x squared times x is x to the third plus. I'm not finished because I still have to multiply x squared by delta x. And that is the only thing that you can do is you write them next to each other. That's all you can do. Okay, that's distributing the first term x squared over x plus delta x. Now I'm going to take the middle term, 2x delta x, and distribute it to x delta x. This 2x, if I multiply by x, becomes a 2x to the second power. So those two x's can be multiplied. They're separated from the delta x. So that's 2x to the second. And then, of course, there's the delta x next to it because the 2x has a delta x, okay? And then plus 2x delta x. If I multiply by delta x, that becomes 2x delta x to the second power because you have two of them. So delta x to the second power. So that's the distribution of the middle term over x plus delta x. Finally, plus the distribution of the last term, which is delta x squared over x and delta x. So the first one is going to be x times delta x to the second plus delta x squared. If I multiply it by delta x, another delta x, that becomes delta x to the third because there's three of them, okay? So this is expression x plus delta x to the third. Am I finished? Not really, because I can still combine like terms. So what I'm going to do is, as you notice, there are some terms that are like, so I'm going to combine them. And the way I'm going to do this, I will copy and paste underneath what I currently have. So x to the third, you must bring it down as it is. But when you look at the next two, 1x squared delta x plus 2x squared delta x, that becomes three of them. So all I have to do is change the number 2 into number 3. There's three of them. So 1x squared delta x plus 2x squared delta x, there's three of them. Now 2x delta x squared plus x delta x squared, again, three of them. So that's three of them, and then this one in the middle right there can be removed. And then, of course, delta x to the third. So all this expression is nothing but x plus delta x to the third, okay? Remember what I needed. Okay, let me go back. I needed an x to the third, which transitioned into x plus delta x to the third. Then I need an x plus delta x to the second. As you know, we already computed this in the previous step. I can show you when I computed x plus delta x to the second. This is x plus delta x to the second right there. So we started with x plus delta x squared. So let me copy all this and then I'll adjust it for you. Now, why we need them? Because if you look at the expression, we have an x to the third next to the 5 and then an x squared next to the 3. And then I thought of separating them, computing them individually to make it easier to plug in, okay? And that's what I'm trying to do. So this is the foiling part that you see in there. And then now, here's the final. And then I'm going to highlight both of them. The term in the middle, they're both like. There's two of them, so I just merge them in one. Here's the final. So this is x plus delta x squared in blue. And this is x plus delta x to the third in yellow. Okay? Now, what we are going to do with them, I'm going to go back to this expression. This is where we are. And I'm going to plug them in. Here's the expression. And I'm going to plug them in. So what am I plugging in? I no longer need this x plus delta x to the third. I'm going to replace it by this entire expression right there. So next to the 5, I'm going to put a bracket sign. In yellow, you see the substitution. Okay? Okay, let me back up. It's not this one. It's the next one. So x plus delta x to the third will be substituted by the yellow one. Here's the substitution inside the bracket sign. So x plus delta x to the third is substituted by the yellow. Minus this x plus delta x squared will be substituted by the blue one. Here's the blue one. Inside the bracket. And then minus 4. Now what remains for me is to take this expression and then distribute the 5 over the yellow one, distribute the -3 over the blue one. And then that's going to be what I need to plug in to the ratio, okay? So let's go ahead and do that. So we have 5 x to the third plus 15, because 5 times 3 is 15. And then I have x squared plus delta x okay? Then we continue again with a positive sign. 5 times 3 is another 15. Then I have x, delta x to the second. Let's see if we can eliminate the color. There you go. Then I have 5, delta x to the third power. Let's see if we can eliminate the color. There you go. So that's the distribution of 5. Now the distribution of -3. So -3 x to the second power. Minus 6, because 3 times 2 is 6. X delta x. Minus 3 delta x to the second power. And then we finalize with minus 4. So this entire expression is f of x plus delta x. Now, where this long expression will be plugged in, this will be plugged in the ratio of f of x plus delta x, f of x plus delta x minus f of x over delta x. So let's do that. Here's the ratio. The ratio is equal to f of x plus delta x is this long expression right there. So let me copy that. Okay. And then this is only f of x plus delta x. Then minus f of x. Remember what f of x is. And then I can copy f of x and bring it next to the f of x plus delta x. I think will be good to do that. So if this one is f of x plus delta x right there, and then the other thing that I can do is I can bold them, I think. And then I can use the color red so you can see it, okay? It looks like if you bold this one, it requires more space, but at least it's in the red color, so you can look at it. There you go. So the top one is f of x plus delta x. Then will be a minus f of x. So in front of this expression of f of x, there's a minus f of x. So if I put minus in front of it, every sign of this expression is going to flip. So 5x to the third is going to become minus 5x to the third. The next one that is minus 3x squared is going to become a plus 3x to the second. And then the last one, minus 4, is going to become a plus 4. And then, of course, the denominator is a delta x. Okay, let's continue. Again, I'm going to look at this expression, f of x plus delta x. That's the ratio. And then I'm going to study and see what I can cancel out. And then I'll identify them by using colors. So let's start with 5x to the third, which is the color green. Do I have a minus 5x to the third? Yes, I do, right there. So that's a green. Those terms will cancel out. Then I have a minus 3x squared, which is color, not colored green. Let's try to pick a different color, yellow. And then I have a positive 3x squared. So let's make that yellow. And then I have a minus 4 is a number which I'm going to make it blue. And then I have a positive 4 at the end. That's a blue. So all these terms are canceled out. So now what remains for me is this term that I'm lighting. So let's put an equal sign in there. Let's put the sign of the ratio. So these terms, number 2, number 3, number 4 are still there. And then these two terms are still there. So these are the remaining terms in the denominator. And then, of course, delta x still remaining. I mean, those are the terms, the remaining terms of the numerator, and delta x in the denominator. In the next step, I'm going to factor out a delta x. As you notice, there's a delta x at the top that they all share together. So that means I can factor it out. And then if I factor out delta x, I'm going to copy this expression and then adjust. So I'm factoring out a delta x. So if there is only one delta x, that means I'm going to eliminate it. So the first term has only one delta x, that is gone. The second term has two of them because of the square. So one of them is eliminated, but there's still one remaining. The third term has three of them. One is eliminated. But the denominator, since we had three of them, that becomes an exponent 2. Delta x at 6x minus 6x is eliminated. And then the last one, I notice that I have 2. Oops. So now I'm left with only 1. Okay, and then square bracket. Now what's going to happen with the delta x in the denominator? With the delta x I see at the top, factor out, the purple one, both of them will cancel each other out. And then that allows me to say that this ratio, which I'm about to take a limit, it's only equal to this expression inside the square bracket that I'm going to try to copy. Let's see if I'm going to be able to successfully to do that. There you have it. And then now what I can do is I can grab the limit notation right there and then take the limit of this expression. Here's the limit definition. And I'm going to grab the limit notation. Delta x goes to 0. And then what the expression is that I'm taking the limit is this long expression that I simplified algebraically. Okay. Now, that means wherever I see delta x, I'm going to make it a 0. Everything else stays the same. So the first term does not have a delta x. So that's going to stay as it is. Plus, second term, 15x will be multiplied by a 0 because delta x is 0. The third term, the 5, will be multiplied by 0 squared because we have a delta x squared. Minus 6x is going to stay as it is, and minus 3 times delta x, it's going to become times the 0. Okay, so what is this limit? The ones with the zeros will be eliminated, so what remains is just the 15x squared minus 6x. That's it. So what is exactly the meaning of this? The final answer, using the limit definition, I was able to compute the derivative of the function f of x, defined as f prime of x, and then this is equal to 15x squared minus 6. And that's the final. And I highlight in blue, and that's the solution. Now, as I mentioned, I'm going to do this using basic rules of the derivatives. So what is the shortcut if I use the basic rules of the derivatives? If I use the basic rule of the derivatives, then the very first power rule must be used. So if you recall it, I shared with you some of the rules of the derivatives. So if you have x raised to the power n prime, we always use square brackets for the derivative. Then this is known as a power rule. That's going to be n times x to the power n minus 1. So if you have a power, x raised to the power, that's the rule that you need to apply. This is known as power rule of derivative. Another important rule that I would like to mention, if you have a coefficient, which means a number in front of the variable, we do not differentiate coefficients. We take them out. But if you have a constant, so here's the coefficient k that is multiplied by a function f of x, and you're differentiating. You do not differentiate k, you take it out. You're only differentiating function f of x. Okay, so that means k equals coefficient. Another rule that is extremely important is the constant rule of the first order derivative. So if you have a constant, then you differentiate and the derivative is 0. C equals constant number without variable. And then with that in mind, let me pull the function 15 first. That's the one that you're going to do. Or you know what? You practice on this one on your own. So I'm going to do this one. And you're going to see if I'm going to get the same outcome. Remember, the outcome is 15x squared minus 6x. So now let's try to do this using the basic rule of the first order derivative. So we're trying to find f prime of the variable x. So that's going to be differentiating 5 x to the third. By the way, later on, you don't need to show all this work. We encourage students to get directly into the final answer, but at the beginning, it's important to show all these steps. Even when you use the basic rules, this is how you get familiar with the rules and you learn how to use them. minus. Okay, so there are a couple of basic rules. The first one I'm using is the coefficient rule. I see number 5 is a coefficient, so I have to take it out. So that means I'm only differentiating x to the third. I'm not messing up with the signs, so I leave them alone. I just bring them down or bring them over. I see another coefficient, which is 3. I will take it out. I'm only differentiating x squared. And then minus, I see the number 4 alone. That's a constant. The derivative is 0. Constant means a number without a variable. Now, coefficient in front of the variable means that the coefficient multiplies the variable, okay? And then the focus now will be on the remaining derivatives. They both are power rules. So one of them has an exponent 3, the other one has an exponent 2. So what we do, we have 5, which multiplies. Now, we are about to differentiate x to the third. So n is 3, if I look at the power rule. So that means I'm going to bring 3 in front of it. And then exponent of x becomes 3 minus 1. So you decrease the exponent by 1. Minus 3 multiply. Now derivative of x squared. So we bring 2 in front of it. And then exponent of x is going to be 2 minus 1. And then, of course, minus 0, we eliminate that. In the next step, as I said, this is the longest possible way of writing the derivative. You don't need to do that. Once you understand the process, you can go directly to the final solution. Remember my goal. My goal is to get the same answer. The first one that required a lot of algebraic work was done using the limit definition. This is the shortcut using the basic rules. But even if sometimes you know the shortcut, the basic rules, you got to follow the directions. If the directions are asking you to use the limit definition, you must use the limit definition to get the credit. Okay, so let's go back and finalize this. So we have 5 times 3, that becomes 15. Now, the exponent of x becomes 2 because it's 3 minus 1, so that's 15x squared. Minus 3 times 2 is 6, and then the exponent of x is 1, is x to the power 1, which we write it as simply x. And then you clearly now see that the two outcomes are equally the same. Notice the amount of the work that I put to find through the limit definition. Very tedious algebraic operations. You have to be very careful with every single step. And then it's a shortcut when you use the basic rules to go through the computation process. So sometimes, as much as we like this idea of using basic rules, we have to be very careful in terms of what the directions are saying. So it is always worth to pay attention to the directions, okay? That's what I'm gonna comment on. And then trying to, let's see if I can underline this. I don't like the color. Okay. Okay, so that's good enough. Yep. So this one is basic rules, same outcome, and then using the limit definition. Now for the same thing I did for number 16, I'm gonna say now you try it. So using limit definition and then basic rules. Okay. You already know what the limit definition is. So let me copy and paste so you're not confused. When I say limit definition, that's limit definition. And then when I say basic rules, these are the basic rules. So I'm kind of like copying and pasting them so you can have them. Okay. And that's a good exercise for all of you. And that's going to be the way you learn it. Okay. Let me make sure that I'm saving this. And then saving the PDF as well. I'm going to post it. I'm going to continue to add or maybe create another file, possibly. So let's wait for the PDF file to be generated. And then I'm about to post it right now on Brightspace so you can have it. Yep. There you go. I'm gonna stop sharing. And then of course stop recording. Okay, good luck tomorrow watching the video. Let me know if you have any questions. I'm going to create the second one tomorrow at some point after I return home from the conference. Will be late in the evening, but will be another one that is going to be more focused on the basic rules of differentiation. So more basic rules will be added and then practice with them as well. Okay, wishing you all the best. Have a nice weekend. By the way, happy spring break as well. And feel free to reach out if you need anything. Bye bye.